So hello everyone. In this video I will this video is actually about how mobile communication system works, and I'll also explain about 2G, that is GSM architecture. And this video is actually not only for people with technical background, but for it's also for anyone who has or have had questions similar to the ones noted down here. Before I start, I would actually like to clear certain basic terminologies. As over here you can see, this image actually shows about how a general analogy about mobile communication system looks like. You basically have a user or a mobile phones, okay, mobile systems. You require a mobile tower or the base station, okay, and the base station actually connects you with a central control center, which then connects you with other core networks over the entire world. Okay, now this, why I'm showing you this, because this is how the basic analogy looks like, a mobile general mobile calling analogy looks like, and it's actually same for most of the mobile communication generations like 1G, 2G, 3G, 4G. But what differs is the technological advancements done in each and every generation to provide better and faster and efficient cellular service to the users compared to its previous generation. So it's as good as saying like 2G is better than 1G, 3G is better than 2G, 4G is better than 3G, 5G is better than 4G, and so on and so forth. Okay, the next image is about the how a power level is indicated by a power level detector on your phones. Now remember, mobile phones are called as mobile stations in GSM. That's why it's written over here as MS. Now one thing to note is that power levels in GSM or in entire cellular communication domain, the power levels are actually measured in a logarithmic scale called as the decibel scale, or dB, okay. So that is why the power levels are shown over here as dBm. M stands for milli. Okay, so dBm scale is a logarithmic scale. And why we use that? Because the engineers who were designing, right, they thought that why not, see, remember one thing, the power levels can range from as high as 1000 watts to as low as 10 power minus 14 watts, okay, when you're talking about cellular communication. So for 10 power minus 14, it's like, it's a very, it's not convenient to every time use 10 power minus 14 as and when you want to represent your power level. Okay, so you needed a much more easier scale to represent that smaller values, right? That is why dBm scale is used. So minus 102 dBm, if you want, you can find formulas for how to convert this dBm to a normal unit of watt, okay, and power value. You can convert this into actual power value. I think it will be in the range of 10 power minus 14, whereas minus 88 dBm is in range of 10 power minus 12, that is picowatts, and minus 61 is in nanowatts, around 10 power minus 9 or minus 10. Okay, so this is how the power level detector on MS shows you the strength of signal that you are getting from your nearest mobile tower. In 4G and in 5G, the lowest power level required to make a call or avail different cellular services is minus 102 dBm. Okay, that is as low as 10 power minus 14 watts. Now this is how a 40 watt base station power level is shown. So a base station which is of 40 watts actually transmits the power with a value of 40 watts, and for a user who is located roughly around 18 kilometers, in the range at a distance of 18 kilometers, the power level drops significantly and becomes from plus 46 to minus 102 dBm. That is from 40 watts to 10 power minus 14 watts. You can convert this, you can find the value, or you can find online calculators or the converters also on online to convert this dBm scale into normal value. Okay, so, and this particular image, okay, yeah, one more thing I wanted to show here, that you might have heard people saying that not to go near to a mobile tower. The reason is this only, because at areas closer to base station, there is a signal strength of very high power. So this might affect your, this might affect you, because a higher power signal can have impacts on living things, right, living things. So that is why it's advised not to go near to the functioning mobile tower. Also, you might have heard people saying that mobile towers are not to be allowed to implement it over residential buildings, because the people living in that building might face certain issues like headache, continuing headache, then nausea and all these things, because see, the base station is transmitting with higher power in its close proximity, and that is the reason why it's recommended not to allow base stations over residential buildings. Now next thing I wanted to show is that a geographical area, okay, in cellular systems is actually divided into smaller hexagonal based cells, and each cell is given allotted certain bands of frequency. Okay, so in GSM we'll learn about what frequency spectrum GSM uses. So entire, and the base station in each cell, the base station is located at the center as shown over here. And remember one thing here, and yeah, as I say that a base station is located at the center, and each base station in that particular cell is allotted certain set of frequencies. And over here in this picture, each cell is having different color, which indicates different set of bands allocated to that cell. And one more thing to note over here is that same colored cells are never in close proximity to one another. They are always going to be separated by certain distance, which is called as the reuse distance. Now, and why do they do this? Because see, in for every generation, whether it be 2G, 3G or 4G, you have a limited spectrum, okay, a limited frequency bandwidth, right? Bandwidth is limited for every generation, and you want, and the cellular providers actually want to use this bandwidth in most effective and most efficient manner without wastage of any kind of frequency, right? And to do this, they implement a technique called as frequency reuse. Okay, and to implement this frequency reuse, you have they separate the geographical region into different smaller hexagonal shaped cells, and a group of certain cells forms one cluster. So this image is basically about 7 cell per cluster model. So one cluster consists of 7 cells, and this cluster is repeated one after the another. So you can see this cluster is very close to this cluster, but you can see the cells in the cluster are arranged in such a manner that cells with the same frequency allocated are never close to one another. So let's say, for example, just an example, this cell 1 is allocated frequency band from 300 mega let's say 900 megahertz to 900 megahertz to 950 megahertz, and same yellow colored cell over there is having 900 to 950 megahertz frequency band allocation. So you don't now want that these two cells be close to one another, because this will lead to interference, and interference leads to errors. Okay, that is the reason they are separated by certain distance called as D. Okay, so yeah, these were the certain terminologies which I wanted to show you all before I start. Now let's talk about the GSM, and let's see about some specifications about GSM. So GSM is called as Global System for Mobile Communication, 2G worldwide. But for USA, when 2G was implemented in USA, it used multiplexing techniques different than what majority of the countries use. Okay, so USA, the 2G system architecture in USA used a multiplexing technique called a CDMA. That is why the 2G generation in USA was called as the IS95A or CDMA. See, every generation is given a specific name, and that name represents various technology, or so that name actually represents various technologies and what you can say, hardware or protocols, various technologies or protocols used for that particular generation. Likewise, in GSM, the GSM uses GSM, that is a 2G for India and different other countries. Majority of the countries in the world, they use a multiple access technique called as TDMA FDD. Okay, so the name GSM itself represents that that architecture or that system basically uses TDMA and FDD as its multiple access technique, because as I already said that every generation uses some kind of multiplexing technique. Okay, because that multiplexing techniques allow numerous signals to occupy a single transmission channel, which actually optimizes the use of available bandwidth. So as I already said that the cellular providers want to use that limited spectrum in the most efficient manner. That is why they use different multiple access techniques. And why they use this multiple access technique? Because a mobile tower have to provide, calling or cellular services to hundreds of user at any given time. Okay, that is why they have to implement this multiple access technique. So all their information is carried by a single transmission channel that actually acts like a sea of information, and multiplexing helps in avoiding mixing this information from one user to another. Okay, and TDMA, which is actually stands for time division multiple access, is basically divides frequency in allotted spectrum for multiple users. Okay, so as you can see over here in this image, so this is how TDMA looks like. Okay, in the this particular axis represents the frequency, and this axis represents time. So every frequency is allotted for certain slot of and this slots, there are 8 time slots. So let's say a caller 1 is wants to make a call, and he is allocated this f1, he is allocated downlink f1 frequency for this slot 1, that is red color slot 1, and uplink frequency of this red color f1. Okay, slot 1. Now once he have when the once he the time for which he is allocated expires, he will be given a certain new frequency and a new time slot, same, so that any other new user can occupy this red slot instead of that cell user 1. Okay, so this is like, it's like a time based leasing of frequency for the users. Okay, so they so in GSM they use this technique for efficient use of allocated spectrum. Now GSM systems were actually divided into two operational RF spectrums. For low crowded region, GSM 900 is implemented, and for crowded regions or very crowded metropolitan cities like Mumbai, GSM 1800 is implemented. Now the name itself suggests that GSM 900 might be using frequencies which are around 900 megahertz, and GSM 1800 uses frequencies which are around this 1800 megahertz. So also the telecommunication links in a cellular network consist of an uplink and a downlink, because uplink and downlink are necessary to provide full duplex communication based capabilities, right? So uplink represents a communication link established from your mobile phone towards your base station, that is a mobile tower, and a downlink represents a communication link established from a mobile tower towards a mobile phone. So these are uplink frequencies, and these are downlink frequencies for GSM 900. Same for GSM 1800. Okay, so there is uplink and downlink. So over here you can see, and the uplink and downlink are actually divided by 20 megahertz guard channel, guard band, you can see. So the guard band is actually just used to avoid interference between uplink and downlink frequencies. That's it. Its use is that much. That's why a guard band is used. And one more thing to note, that spectrum bands are divided into 124 channels of 200 kilohertz bandwidth each. So uplink, which is talking about GSM 900, uplinks which are from 890 megahertz to 915 megahertz in GSM 900. So the entire frequency band for uplink and entire frequency band for downlink is divided into various slots, and each slot is called as a channel. Okay, and a single channel in GSM is called as an ARFCM. Now one thing to note, do not confuse that this one slots, that is a one single channel, represents only one frequency. No, these channels are made of certain frequencies. Like for example, this 0th channel over here is actually made up of frequencies from 890 to 890.2 megahertz. So the bandwidth of this channel is nothing but 200 kilohertz. Okay, don't just remember, this is very important, because many people confuse that one slot is actually indicating a single frequency. No, it's not like that. Okay, so channel is a nothing but a group of frequencies, and in GSM the channel bandwidth is 200 kilohertz. Okay, so yeah, this was the introduction about your GSM architecture. Now let's actually deep dive into the GSM architecture itself and see how does the architecture looks. So this is how your GSM architecture actually looks like. This is your access layer, that is access layer consists of you as a user who is having a mobile phone to connect with the GSM architecture of your selected or your preferred cellular network cellular provider like Jio, Airtel, or etc. If you are for whatever cellular provider you have in your country. Okay, so let's see about what a mobile phone use. So mobile phone is very important and one more thing, mobile phone in GSM is called as mobile station, right? So a mobile station is very important, and it's actually a necessity in order for you to access the GSM network and avail various cellular services. So mobile station consists of display, digital signal processor, SIM, etc. Hardware and SIM are most important terms for any MSc, because hardware, why hardware is important, because you cannot for 5G at the time of me making this video, 5G is trending. So various companies like Samsung or Asus and Nokia and all these mobile companies, they are making new uh, phone models, right? And their models actually have 5G XYZ model, ABC model with 5G support, so and so. What it actually says that that model, the hardware of that mobile phone model is suitable for 5G 5G architecture and 5G applications. So you cannot have a 4G mobile phone to work in 5G, you can say 5G more cellular network. It's not possible, right? Because the hardware of that 4G mobile phone is not made for that 5G architecture. That is why you need a upgradation of your hardware if you want to jump from 4G to 5G and 5G to 6G and so on. Why SIM card is important? Because SIM card stands for subscriber identity model, and it consists of various personal security keys and other IDs necessary to uniquely identify and authenticate users over the network. So in this GSM architecture, we'll talk about a component called as the AUC, that is the authentication center. It actually authenticates you when you buy a new SIM card. You see the when you the vendor tells you to wait for let's say wait for few hours, like 8 hours or 6 hours or 5 hours before you can start getting network coverage, right, from your nearest tower. Why this time is taking? Because that you are actually being authenticated over that particular home network. Okay, so that authentication takes time, and that authentication happens based on your personal security key and other IDs which are associated with the SIM card that you buy. Now, mobile station provides access to GSM architecture for various types of services for the user. Yeah, so you require a mobile station in order to access various cellular services over the GSM architecture. Now let's talk about the telecommunication, this wireless link between the mobile phone and your mobile tower, that is MS and BTS. So as we already discussed, that a forward link, that is a downlink, is a link from a fixed location, example a base station, to a mobile user, because the base stations are always fixed, they are not moving from one point to another, whereas we users are moving from one point to another. That's why the reverse link, sometimes called as a return channel, is the link from a mobile user. Mobile doesn't mean your mobile phone, mobile means a user who is on the go, that is who is moving user to a fixed base station. Okay, and these are various uplink and downlink frequencies for the GSM. Okay, now let's talk about your actual mobile tower. A mobile tower in GSM is called as a base transceiver station, or BTS, or sometimes for ease it's also called as BAS, that is base station, BS. Okay, so it's responsible for radio resources, signal processing, signaling, link management. The GSM BTS supports a wired link of 64 kbps and wireless link of 13 kbps. Now see, why wired and wireless? See, if you see the BTS, all the stationary components in this architecture, they are all connected via a wired link, whereas all the components which are moving, like you, the user, that is your mobile phone, they are connected with your mobile tower with a wireless link, because a wireless link is necessary in order for your system architecture to support mobility. Okay, whereas all these stationary components are connected via a wired link. And why not wireless? Because see, a wired link is always much more better than a wireless link. Okay, wireless link are solely used for the purpose to support mobility, because wireless links are actually more error based as compared to your wired links. Okay, and they are not that much accurate as compared to wired links. That's why stationary components are uses a wired link. Okay, and in GSM the BTS support wired link of 64 kbps and wireless link of 13 mbps. So basically the bandwidth of your GSM architecture ranges from 13 kbps to 64 kbps, and it depends upon whether the link is wireless or wired. Okay, the BTS also performs encoding, encryption, multiplexing, and modulation of the user's message signal, and then feeds the signal to the RF, that RF signal to the antenna. So it's but obvious that your message signal have to be encrypted and encoded, and then various multiplexes techniques are used, and then modulation is done. Then modulation means low frequency message signal is mounted over a high frequency carrier for transmission, and so on and so forth. Okay, so BTS also communicates with the mobile station using multiple access techniques. Okay, and GSM uses TDMA or FDD as is multiple access stacking, which we saw in the introduction slide. And the BTS also reports to BSC for access and control specific tasks. Okay, so now let's see what is BSC. BSC stands for base station controller. It performs radio resource management, manages handoff, reserves radio frequency. What does handoff mean? Handoff means that when see, the GSM architecture actually supports mobility, right? So let's say when you are traveling in a train, you are calling to, you are on a call, you are on a call with your friend, right? And you are traveling from there in train from one point to another, let's say in a car or even on your cycle or so on, right? So you are frequently changing your region, right, from one point to another. And if let's say when you are moving, you are going from the coverage area of one mobile tower to the coverage area of another mobile tower, in that case, and still when and still if you are on a call, then your call have to be transferred from that older base mobile tower coverage to a newer mobile tower, right? And this is called as the mobile call handoff. In the simplest form, I can explain it in this way. So this handoff should be performed very effortlessly, so that the user cannot even detect that, right? And this is managed by the BSC. It also reserves radio frequency. So what does this reserves radio frequency is that we saw that the entire geographical region is divided into various hexagonal shaped cells, and each cell is provided with a set of frequencies in such a manner that that set of frequencies it's not matching with any of the base stations in its neighborhood, right? So this is achieved this is achieved by the BSC. It reserves radio frequencies by looking that whether there is no cell in the neighborhood of that particular cell of interest which is having same set of frequencies, otherwise it will lead to interference and errors, right? And BSC is responsible to control several hundreds of BTS. So BTS means your mobile tower. So hundreds of mobile tower are actually controlled by a single BSC. BSC forms the bridge between your BTS and mobile switching center, that is MSC. BSC is also in charge of frequency administration, maintaining proper signal levels, and handles successful handoffs in BSS. Okay, so now let's see about MSC. MSC is actually the heart of GSM network, because it is the reason why you can make call to from India to someone who is outside Mumbai. Okay, so outside Mumbai or located anywhere in entire world, because the MSCs are like gateways to connect you with other core networks, okay, over the entire world. So MSC manages communication between different GSM networks and other core networks, just as I said, and responsible for routing voice call and SMS as well as other services. It also acts as a bridge between BSC and other core network, whereas can control up to hundreds of BSCs. So just like a single BSC can control hundreds of mobile tower or BTS, similarly a single MSC can control hundreds of BSCs. It also handles mobility and handover requirements during the call, and takes care of various charging and real-time prepaid account monitoring. Okay, now your MSC is actually comprised of different sub-components like HLR, VLR, AUC and OMC. Let's take a look about them one by one. So now remember, before I start explaining HLR, remember one thing, that whenever you buy a SIM card, your SIM card is assigned with a home network. So if you have ever noticed that when you get a call from someone, you can always see the name of the region from where the call is coming, right? So for example, some number and then Mumbai, India, or let's say Ahmedabad, India, or let's say anything like Goa, India, so and so forth, right? You can literally see the name of that home network of that phone number, right, where that phone number is registered. So that home network, that registration is actually done in HLR. So HLR is a database that contains data regarding authorized subscribers using a global system for mobile communication core network. Okay, so the HLR stores information not only ranging from your phone numbers but also the current location of subscriber. Now you will ask, why do actually HLR need the information about the location of the subscriber? The reason for that is mobile IP. If you are interested, you can search about mobile IP on Google. You will see that mobile IP is actually necessary to support mobility. So in order to make a call when you are on the go or moving from one point to another point, you can still make a call, and the reason for that is the mobile system architecture actually have certain knowledge about your location, that where you are moving. When you switch from one mobile station to another mobile station, your your information have to be your receiving information has to be transferred from that older base station to the newer base station, and it is only possible when the mobile architecture, mobile communication architecture of that region have certain location based information about you. And that is the reason HLR also stores certain current location information about you. Now don't worry about the security and all these things, because these systems are so much hard to hack, and so the security is of very high level, right? So some data content in HLR includes IDs like MSISD and IMSI and SIM. Cell phones and their corresponding SIMs are mostly on the move, therefore HLR is used to identify their last known location. This information is updated each time the device is transferred into another location. Okay, and HLR assists MSC in its functioning and providing flawless network service to the user. Now let's see about the VLR. VLR, as the name suggests, that is the visitor location register, acts as an it's like, so whenever let's say you are moving, your SIM card is from Mumbai and you are going or residing to another city. Let's say for example you are going to Ahmedabad in Gujarat, right? Now when you are in Ahmedabad, you will be still be able to make calls, okay, via using the cellular providers architecture of Ahmedabad, right? And why you are still able to make calls and all these things properly, because the VLR of that particular, see, you are actually acting as a visitor for that Ahmedabad's network architecture, right? You are like a visitor to that, and that architecture have to store certain information about the visitor who is visiting its architecture. Okay, so that information is stored in VLR for temporary basis. So it's not necessary that you stay in Ahmedabad for some couple of months or couple of days, but you can even reside there. You can, and even if you reside in Ahmedabad, you can still keep using your Mumbai SIM card. And the reason for that is this, that the VLR is responsible to store your information. So okay, so that is why the VLR performs mobility management or also handles call handling functions. So VLR is also one of the very key components, okay, which assists MSA in its proper functioning and provide proper cellular services to the user. Now let's talk about the AUC. AUC stands for Authentication Center. As I have already mentioned about AUC when we were talking about the mobile station, AUC is the one which validates any security information management card attempting network connection when a phone has a live network signal. So anyone who is just who is not authorized to access the system cannot access the network architecture, right? So because see, whether it be in India, there is Jio, then there is Airtel, then Idea, Vodafone. All these cellular providers will not want any user who is not a validated user to access their network, because they don't want any third party subscriber to come, or a third party hacker to come and access their network. They will not need that. So for that, there has to be some kind of validation based mechanism, and this is what is done by the AUC. So AUC provides security to ensure that third parties are unable to use the network subscriber services. Each network SIM card is assigned an individual authentication key, KI, and this key and a matching key is contained in the AUC. So remember, when you buy a new SIM card, they tell you to wait for 8 hours or 5 hours and so forth, because you are being authenticated, and and the AUC is the one which authenticates you. And remember one thing, whenever you make a call, not just one time, each and every time you make a call, it takes certain time, right, before you can hear that ringing sound, right? And then for that certain time period before you hear the ringing sound, you are actually being validated. Now how does this validation work? It actually, what happens is that your mobile phone sends a security key, that is KI, from your SIM card towards the mobile station or the base station, and that base station, that is the BTS, sends this key to MSC, and from inside MSC it sends this key to AUC, and inside AUC it actually matches the key. A similar key from AUC is also taken, and there is actually a matching happening between the key sent by you and this key which is received by AUC, and this matching actually takes place inside the VLR. Now VLR tries to matches both the keys, and if that both keys are matching with one another, only then it is your call will be placed, right, and you can hear that ringing sound. But if it's not matching, you will not be allowed to make the call, right? So this is how there is this mechanism of matching or authentication takes place. The key, even this KI is also remains hidden from the SIM card owner. Even you cannot know the that is ki of your sim card. It's encrypted in such a manner, because it's done to so that it protects the network operators from fraud such as sim cloning, and through enabling user identification verification and ensuring call confidentiality. Okay, so it's done, so it's remain hidden from the sim card owner, just to avoid fraud and sim card cloning and all this security concerns, right? Now let's talk about the OMC. So OMC actually stands for Operation Maintenance Center. It's it's like a maintenance center which looks after software updates and all this stuff, right? Because see, every system architecture has they'll be using some kind of software or another, and the software have to be updated from every now and then, and that upgradation and all these things are taken care by the OMC, because as it's also written over here, it actually monitors and maintains performance of MS, BS, BSc and MSc. The three main functions of OMC are to maintain all telecommunication hardware, because the hardwares are always associated with firmware updates and all this. So to keep the firmware updated on a regular interval of time, OMC is responsible for that. It also manages the charging and billing procedures, and also manages all the mobile equipments in that system. Okay, now other networks means that the MSC is actually connecting you as a user to someone or your receiver. See, it's not necessary that the person whom you are calling is located over this network only, over your home network only. It's not necessary. You might be calling someone who is located in Mumbai only, and who comes under the same network, but you might also be calling someone who is located anywhere in the world, and anywhere in the world means other networks, right? And to connect you with someone who is located over the world or other core networks, MSC is responsible for that. Now let's see what does this other networks in GSM means. In GSM, other networks consist of PSTN and ISDN. PSTN is public switch telephone network, which is a circuit switch based telephone network. Okay, and ISDN stands for integrated service digital network. GSM architecture also connects a user with other packet switch networks as well. So there are basically two types of networks, a circuit switch and a packet switch. A packet switch network will dynamically route the message packets, whereas a circuit switch will actually allocate a path, a static path before the packets can be moved. Okay, with the advancement in different cellular generations like 3G, 4G, 5G, internet services are also made available. So for 4G and 5G, these other networks, as you can see over here, this other network basically represents the entire internet, not just PST and ISDN. It actually represents the entire internet. Okay, so this is how your GSM architecture looks, and these are all the necessary terminologies which I explained you. Okay, now let's see some key comparisons between different mobile cellular generations. So you can see every generation is adding new set of services. So 2G was having only calling and SMS based services, but 3G was supporting not only calling and SMS, that is services given by 2G, but also had added some sorry, added some new services like MMS and mailing, and also had internet access. Same thing for 4G. It also added its own new set of services, whereas in 5G it also added new services like IoT, AR, VR, Ultra HD streaming, cloud gaming, so and so. Now this is also this image shows some key difference between 1G, 2G, 3G, 4G and 5G. So one thing to note over here, as I said, access techniques, that is 1G uses FDMA, 2G uses TDMA or CDMA, 3G in the entire world uses CDMA. TDMA was used by GSM, CDMA was used by US based 2G systems called as IS-95, whereas 3G over the entire world or in every country is same and uses CDMA. Same thing for 4G. For entire world, 4G uses CDMA, and same thing for 5G, it uses OFDM or BDMA. Now okay, and the core networks, as I said, for 4G and 5G, the core networks were nothing but the entire internet, that is within palm of your hand. You can access, that is using that just a small mobile phone which is like a mini computer, you can access the entire internet using 4G and 5G. Okay, so yeah, this is how what is the comparison between different generations. And finally, thank you, and I hope this presentation helped you to get a gist about how terrestrial based mobile communication system works, and it also provide you a a good visual approach about how GSM architecture looks and functions. So one important note for those who are thinking that a satellite based system is responsible for your mobile calling, you are actually partially incorrect and partially correct, because as for military based and remote areas, satellites based systems are actually involved, but mainly for metropolitan cities or crowded cities like Mumbai, and so satellite based systems are not used. Mostly speaking about 4G and 5G, satellite based systems are actually not used for crowded metropolitan cities. The reason is simple, because it might be very expensive, to manage frequent calling needs between so many users, right? Because in the crowded region, you can expect a millions of user active at any given of time, and it's simply not feasible to route their calls over from a ground station towards satellite and again bring the signal back from the satellite bureau. Okay, it's very expensive, but for 6G, they are going to work on hopefully there will be technologies advancement, so that satellite based systems might be feasible to implement even for crowded regions as well. Okay, so thank you.